Hello, my name is Robert Ipax Dinamite, and my name is Robert Ipax Dinamite, and welcome to the video where I explain full stack development. So full stack development, a level on top of the other. Uh, First, I would like to introduce the lesson by explaining how programs work. So the source code, if you ever heard of this term, source code, so the source code means the code you write for a given program to run. You can write the source code, your source code in any programming language. So programming languages use rules like grammatical rules, or they're not really grammatical, they're rules so that the computer may be able to understand what you want to instruct it. And these rules are known as syntax. So some example of our rules could be these ones. You see console.writeLine, that works for C Sharp, console.log, that works for JavaScript, and for Python it's print. And what these sentences do is they print something in your console or your terminal. To make it easier to distinguish between the source code and plain text that we write in our everyday lives. So language, each language is saved with a file name extension. For example, for C you have .c, for Python you have .py, and for JavaScript you have .js. There are many tools out there for the general public to use to instruct computers to do things, but to communicate with computer, the most efficient way to do it is to use a programming language or to write a program. Right. So programs are merciless. They do not tolerate that you get a typo or anything like that. So to avoid that, we have what we call code editors or IDEs. An IDE is an integrated development environment. An IDE provides a text editor with tools that help a programmer to avoid syntactic error, like to avoid errors in their syntax, or other inconsistencies like to write syntax that doesn't work. So some programmers like to use the ones that help them the most, and other programmers love to use the ones that help them the least. Why would you want to do that? It's because most times these programmers who use tools like V or Vim that do not correct you as much as something like Virtual Studio is because they want to know how to write each and everything and always be ready somehow to write something on the go without having to rely on autocorrection and autocompletion that is provided by these code editors like Visual Studio, Atom, or Sublime Text. So to maintain the code that the developer or the programmer writes, there is something called a version control. Version control or version control systems, what they do is they record all the changes that you make to your code and all the changes that you make to your program. And so that when your program isn't running properly in the future, if you have changed something, you may go back to where you were and find out or the cause of it, and or maybe revert back to what you had before. So furthermore, version control tools allow each developer to work together on maybe one single program, and to to know who wrote which part of the program, and to be able to integrate things that work and things that don't work for the whole program to keep going. It basically allows to not have disorganization in your code, and also to keep track of what's going on. When something breaks, you may go back to what worked before. So there are several online services that allows you to store your programs on repositories, to store your source code, and to allow you to see what was made before, the changes that were made, and all that. Um, some of these programs, uh, some of these services are GitHub, Gitbucket, GitLab. There's also for the GNU project, that's for the Linux stuff. They have Savannah, and some tools that help while you're coding to to record your programs and each and every move you make. Is the most popular is Git. Some still exist like Subversion and Mercurial that does the same work but in a different manner. Um, they both they both have the same goal, but they have different strategies. So programming languages and paradigms. Mm. So a paradigm is a pattern or a way of doing something, or a way of seeing something. Um, so a programming language paradigm is technically like a way you write the code, and the programming languages are kind of differentiated or distinguished according to their paradigms. And there exist several paradigms. The programming language is procedural when the instructions presented in the source code are executed in sequential order. That means that each line you write, the first line is executed before the next line, and so on. So that's a procedural paradigm. And for example, the programming language that uses this kind of thing is C programming. You may have this in many languages actually. Python does the same thing. All the programming languages I've used does the same thing, but they also add on other paradigms that you can use for your program to keep working. Um, so these other additional paradigms are something like object-oriented programming, where the programmer creates classes or independent subsets where the components that you've created on the side can be used in the main program. Another paradigm is functional programming. In functional programming, the programmer creates functions, and these functions can be reused many times in the program. So if you have code that is recurrent in your program, you may put it in the function so that you may call that function every time you want to use it. Another paradigm is called declarative languages, or declarative programming. So declarative languages, um, they they allow you to state what you want to achieve, and then they do the work for you instead of going to code how the results you want are going to show up or something like that. You make a query or a statement, and the program go to find it using its own ways and bring it back to you in the format you would like. Some examples of this are SQL. Instead of you having to code your way to the data is retrieved by writing a query statement. All right, let's continue. So we have compilers and interpreters. So interpreted languages and compiled languages are two different approaches to executing a computer program. There exists something called machine language, which is also known as machine code. It's a low-level programming language. A low-level programming language meaning it's more close to the CPU, and there's not much subversion that is not built too much with many subversion layers. So it's closer to the computer CPU, and so it can be executed more quickly. So when you code something, it is compiled into machine language, which is closer to, well, it's a low-level programming language, which will instruct the computer what to do. So each computer has its own unique machine language that is specific to the hardware architecture. So whenever you code a program, it's compiled into that, and the program runs afterwards. A compiler is something that translates the source code you've written into machine language. However, not all programming languages are compiled directly into machine language, because machine language, if it's unique to its own hardware architecture, then you may not program something that will work on each and every machine you get to. So to solve that problem, some programs are compiled into something called bytecode, which is another low-level language instructions that is executed by a virtual machine that is known as a runtime, rather than directly by a computer's processor. Some examples of these languages that are compiled into bytecode are Python, Java, C#, Ruby, and more. So when you install the program on your machine, you also install this virtual machine that will execute the program. There's something also called interpreted languages. So interpreted languages are executed directly from the source code, line by line on the go. Like when you write one line, it's interpreted into machine language. The beauty of interpreted language is if you write something in an interpreted language and you take it away to another machine, the other machine will also read line by line what you wrote and put it into machine language. And so you can use your code mostly everywhere. But because the interpreted languages are interpreted line by line, they're slower than their counterpart, which are these compiled languages. So let's continue. Now we're reaching web application architecture. So how everything is stacked. So a stack is like, well, a stack is putting something on top of the other. So how these languages are stacked together, it's called full stack development. So the web application architecture is the stack of the web, or how, in general, how it looks like. So we have the clients and we have the server. A client is a computer, a phone, a browser, an application that a user will use to send requests to a database or send requests to a server, and a server will give them back information. So, for example, this whole screen we have is a client, and if I had like buttons to click so I could see a video from some server, like for example when you're using YouTube, um, what you're doing essentially is that what you're seeing in your screen is is let's try that. So what you're seeing in your screen is essentially the client, and what's coming back to you when you click a button to see some video is data that comes from the server. Mm. Let's wait a moment. So, for example, these videos that are refusing to load. If you click one of them, what you're doing is you're sending a request to the server. And if you send a request to the server, it will bring back to you uh, it will bring back to you the data you wanted, and the data exists on the server. So the client and server communicates with each other. The client is your computer, or the web page you're using, or the application you're using on your phone. A user is different from a client. A user is a person that is using the client, and a server serves to the client. It's kind of like a restaurant thing. A server serves the client. The client is the application you're using or the computer you're using, and a server is another computer far away in the world that you send a request to, and it sends you a response. The response is the data. So um, the client and the server communicate through something called a hypertext transfer protocol. So this hypertext transfer protocol has rules, or for like a formatted way you communicate that computers must communicate in, and to to make sort of a good request that is written in a proper way, or that is accurately directed to find a specific thing on the internet. We programmers use something called APIs. So an API is like small instructions, or there's a set of instructions that fill up maybe something like a form of hypertext transfer protocol, or of HTTP, and is sent to the server. The server also takes this form and fills out everything that is related to what you want, including the data that you want, and sends it back to you. So I will keep explaining that later. There are a variety of web clients. So we have a browser, which is a program that makes visible the content of HTML along with the modifications of CSS and JavaScript and the other components. The browser has a rendering engine, and rendering means pasting something. So the rendering engine will show you everything that was built with HTML and CSS and JavaScript. And if you use any program that to create this too, it basically will show you how it looks, the results. So a web application or a web app is a program accessed by a browser or packaged in a mobile or desktop application. So unlike the client loaded in the browser, the HTML and the necessary component for a native client to function are locally present since the installation of the application. So basically, when you install an app, you're installing the HTML, the CSS, and everything that will make the app look the way it looks, and it's right there. And maybe when you go to get some video from there, consume some picture, you send a request to the server that brings it back to you to your client that you installed when you installed the app. That's a web application, but a web application is basically both from a browser and both from these applications we install on our phones and everywhere. We have something called progressive web apps, and progressive web apps, what they do is they allow the user to have some functions that do not require immediate communication with the server. So you may maybe play a game on your phone, and it doesn't have to communicate to the internet for you to be able to play that game. That's a progressive web app. So resources that may contain sensitive information, such as access to your local files on your computer, your geographic location, or the use of your camera, your microphone. They required is the user authorization, which is your authorization, before the application is able to use them. So for the browser has all these layers of security where it does not allow each and every client or each website you go to use all these things unless you give it permission. And for the phone or for a tablet or anything you're using, upon installation, it asks you what would you like to allow this program to do. All right. So the language of a client, the language we use to build the front end of our application. So the front end stack. The central element of a web application client that runs on the server is the HTML document. The HTML documents present an interface of elements that the browser will display in a structured way and contain the addresses of all files required to correct presentation and operation of the client, for the correct presentation and operations of the client. Sorry. So the HTML document is I like to think of it as like an essay, but with like it's structured with tags or with these elements, and these elements are arranged in the way the programmer decides with their CSS, and they are responsive with JavaScript, and you can basically they're interactive and you can do something with them. Maybe if you click a button, something will turn or something will change the way you want it to change. So the term document, for example, is used in JavaScript code to refer to the HTML document associated with the JavaScript code. In the context of the JavaScript language, document is a global object. So the document as in the HTML document, when you instantiate it or call it in your JavaScript code, what it looks like is like an object of a programming class, and that object has properties and methods that can be used to obtain information from an element on the HTML document or to populate part of your HTML document, like to populate some tag and give it content. So JavaScript as a programming language for the web is sometimes replaced by other languages. And well, JavaScript can not be completely replaced. These other languages will have to compile into JavaScript that the browser will understand, or they will have to become some form of JavaScript for them to run on the browser. So some examples of these languages that are used to code the client part, and that will also be changed into some form of JavaScript so that the browser can see them, are Scala. Now, Scala is a powerful language that will allow you to code both the front end and the back end, and will be compiled into some form of JavaScript so that your browser will understand it. And there's C#, there's Ruby, and there's plenty other language. So these languages, they have libraries or something that will allow them to look like JavaScript for the browser to understand. So a feature that significantly improved the performance of JavaScript application running in the browser is WebAssembly. So WebAssembly or WebAssembly language is some kind of compiled JavaScript that produces source code written in a more efficient low-level language, such as C or C++, Rust, and Go. So basically, you can write a program in C or in C++ or Rust or Go or C# or many other languages, and to transform them into the WebAssembly language, and the browser will understand the WebAssembly language. As an example, something I can give is for people that do civil engineering, or that must use this thing called AutoCAD. Now they have a web app for AutoCAD where you can go there and like design whatever you want to build. But it's essentially coded with C, and it works on the browser. So kudos to that. Technically, any programming language can be compiled to WebAssembly as long as there's a compiler that can translate that language's source code into WebAssembly bytecode or WebAssembly language. Okay, so there are dynamics and static web applications. So dynamic web applications are the type of web applications that generate content or web pages in real time. So for a dynamic web app is like this application where if you click a button, something new will come from the server to populate your web application, and An example I may give is on an email platform like Gmail. When you click the inbox, you will get that one email from the server. And if you want to view another email, you're essentially on the same page, and you can view many things. You can send many requests to receive very much amount of data, and on that one same page. So dynamic web applications are able to populate the viewport with data that is requested by a user. These requests are made possible by APIs. Do not know if I did explain what an API is, but I will soon. So there also exist static web applications. Let's do this. So an API for a dynamic web app will use these methods to request data from your from the server. So it uses addresses and URL forms, uses fields in the HTTP header, it uses the get post method, or it uses the WebSockets. Those are used for video communication, like video calls and audio calls. So APIs are sort of like bridges between programming language. So if I have a programming language on the client, running on the client, and an API is a way that will be used to structure an HTTP request and send it to the server, and the server will send back a response to the API. But the API essentially exists on the back end, and the stuff on the front end is like a way to communicate with the API on the back end. So the server side on the back end, here it is, the HTTP and API. An API can be built using various programming languages such as JavaScript, Python, Java, Ruby, and many others. Notice that these are back-end programming languages, mostly, and can be accessed by other applications using HTTP requests. So an API is in the back-end and is accessed from the front end by other applications using HTTP requests. So in general, an API provides a way for different software applications to interact with each other. APIs use HTTP, which means Hypertext Transfer Protocol, as a communication protocol to transfer data between the client, such as a web browser, and the server where the API is hosted. When a client makes a request to an API endpoint, a specific URL that is, it sends an HTTP request to the server with a specific method such as get, post, put, delete, or many others, and any necessary parameter or data. The server then processes the request and sends back an HTTP response containing the requested data or an error message if there was a problem getting the data. So there is a misnomer called, the misnomer is this small sentence, client-side API. It does not mean APIs that exist on the client side. So the term designing a client API, it does not mean building an actual API on the client side. So instead, what it means is like when you use something like Fetch API, that's when you're designing a client API. So the client side API is actually a set of instructions or methods that are typically written in a programming language like JavaScript and are used to interact with the service-side API, which is the actual API. And uh, we keep saying working with APIs when we say we are talking about the client side, and we keep saying client side APIs or the fetch APIs, but that is sort of a misnomer. The real API is on the back end, and you access it through these methods or functions. And basically, something like fetch is like a method or is from a method or function that you will use to access an API on the other end, on the other side. Um, so HTTP requests and responses. Requests have a few different parts that are important for working with APIs. So we have the method you use to communicate with the other server. You may use the get method, the post method, the put method, or the delete method to change something on the server or get something on the server. To post is to put something on the server. To get is to get the data you want to consume. And there's the delete, which will delete something from the server. So there's what we call the endpoint is the URL where the API can be accessed. So the URL where your data will come from, the address of your data. And there is the header. So additional information about the request, such as the content type and authorization credentials, will be in the header. So that's, for example, if you're logging in or something, the authorization credentials will be in the header. There is also the body where the data you send to the server, let's say, for example, if you want to store something, it's also known as, this data that you send is also known as the payload. The HTTP response will give you back the status code, which is these 3 digits that indicates whether the request was successful or not. 200 means success, 404 means not found, or there are many. There are several. 500 may mean something else, and 300 may also mean something else. There's a bunch, and they mean different things. Sometimes you look for something, then it's not found. Sometimes you look for something, you're not authorized to get it. So there are different situations and status codes for all that. So the header, additional information about your response, like descriptions of your response and other type of caching information are in the header. And the body will contain the data that is returned by the API on the server side, such as JSON or XML payload. Or so the API can also use other communication protocols beside HTTP, such as WebSocket or MQTT, but HTTP is the most common protocol used by web APIs. I hope that helped you understand APIs better. So database management systems. A database is a collection of data that is organized and stored in a structured manner. So when you're viewing like a gallery of on your phone, a gallery of pictures, you're checking a database. When you're typing or preparing a to-do list, you're making a database. So it's structured data or organized data. So database management systems are software programs that enable users to create or modify and to manage the database. Some common types of database management systems include relational databases, NoSQL databases, and object-oriented databases. So for relational databases, this is where the data is stored in these tables and organized in such a way that you may find something in a specific row of a specific column of the table. It's a very effective way and it's very accurate, and that's what SQL does. So an NoSQL database, on the other hand, uses a flexible schema, and a schema is basically like an arrangement of your data, an organization. So it does not require predefined tables. So there are other ways that you may use, other techniques that you may use to access your data or to manipulate or manage your data. And the NoSQL databases use whichever they like. There is also object-oriented databases which use object-oriented programming languages or object-oriented programming to store data and to manage data. The data in object-oriented or object-oriented databases, is stored as objects, like instances of a class, and you may manage them using the appropriate methods for it. A database connector is a software library that provides an application programming interface, like an API, for your program written in a programming language of your choice to interact with the database management system. So the database management system will provide you a way to use a programming language to manage the data. And so this is also a place where APIs are used. So a database connector will provide your programming language with an API, and you can use that API to get the data and change the data how you want using maybe Python, C#, anything you would like. And that's about it. So at the bottom, we have the database management system, and at the top, we have the client. The database management systems, they store your data, and they will be where you will use your backend programming languages to deal with that data. And on top of that, to communicate with the client, there's the HTTP request and responses. And on top, the HTTP request and responses, they are defined and sort of written through with API. So if you think of an HTTP as a form, HTTP as a form, API is like the pen you use to write something with. So on top, we have all the other languages of the front-end stack, which is HTML, CSS, JavaScript, or any other libraries or components you would like to use. React, you may use anything you like. Here on top, I explained the type of applications that exist, the type of web clients that exist, and that's about it. There is also, I talked about compilers and interpreters. for compiled languages and interpreted languages, I thought it might be a good idea for people to understand the difference and yeah, the programming languages and paradigms, the way in which programming languages